2.5 is kind of the start. If you've ever heard people say like, oh, geometry, you do all kinds of proofs. You heard that before? Today is kind of the intro to what those proofs look like. We're not doing any crazy proofs, okay? But you will just get a feel for what proofs will look like so that we can get the hang of how you do them. And therefore, when we get to chapter 4 and we do a bunch of proofs, hey, answered prayers. Prayed for Braden to come. Then when we get to chapter 4, it's just much easier because you've been introduced to it. So this is not like the core of what we do with chapter 2, but it is just a good intro into how this stuff works. So first thing we're going to do is we're going to look at these properties because these are the properties you're going to use as justification in your proofs for why we do what we do, okay? These first 4, addition, subtraction, multiplication, division, these 4 you use all the time. Every test or quiz nearly every test or quiz you take from me, you probably do this somewhere, okay? Maybe not so much in chapter 2, but all the rest of them, you probably do it. The rule is, if you have A equal to B, notice for all of these, if A is equal to B, then, for instance, the addition property says if you add C to one side, then you add C to the other side, and they're still equal equations, right? So it's just adding something versus subtracting something versus multiplying by something versus dividing by something. That gets you that property, okay? The reflexive property, these next 3, there's properties of equality, that's what we're talking about right now, and then there's properties of congruence, which is what we'll talk about in just a minute. But they're the same, it's just are you setting them equal or are you setting them congruent? Okay, so the reflexive property. I always tell people, think of reflexive as a reflection, right? If I look in the mirror, what do I see? Me, right? I see exactly the same thing as is standing on the other side of the mirror. So X equals X, in other words. Brooke equals Brooke. Okay, that's the reflexive property. I see my reflection in the mirror. The symmetric property is if you think of a line of symmetry, right? If I have like X plus H and I flip over this line of symmetry, I get H plus X, right? It's just flip it over. Symmetry, a line of symmetry means you have the same thing on one side that you did on the other, but just in reverse. So that's how the symmetric property works. If A equals B, then I could flip it over and B will equal A. Okay, so it's saying the same thing in a different order. And I know it's like, why do we need to know A equals B and B equals A? Or why do we need to know that A equals A? Duh, we know that. You'll see as we start doing some proofs where these come into play, okay? And then the transitive property, probably my favorite one, is a lot like the law of syllogism. Remember, law of syllogism said if P then Q, if Q then R. We took out the Q's and we were left with if P then R, okay? The transitive property says if A equals B and B equals C, take out the B's and you're left with A equals C, okay? So that's transitive property. And that's actually a lot of times can get confused with the substitution property. Remember chapter 6 of Algebra 1, you did substitution, elimination, that type stuff. Okay, substitution is just saying if I'm playing basketball and I take out a point guard, what do I want to put in its place? Another point guard preferably, usually, right? So you're taking out something of equal value. You hope that it's a point guard that has the same abilities as your starting point guard, right? Take one out, put the same thing back in. So if A equals B, then B can replace A anywhere in the problem. All right, so those are some of the properties we're going to use. Here's one more, distributive property. Distributive property is just saying if you have A times B plus C, I can distribute that A to both of them, and I get AB plus AC. So same thing here. If I were to distribute this, it would be AB minus AC. Okay, that one should not be anything new. We do a ton of distribution in algebra. Any questions so far on just what the properties are? Okay, here's what we're going to do then. They're going to say, what is the value of x, and justify your steps. So this is kind of the basic format for a proof, where on the left side here, they give you all of these steps to be done. And then on the right side, you say why you did them. Okay, so if we look at number 1 here, it says angle AOM and angle MOC are supplementary. How do I know that these two angles are supplementary? Do you know? Yeah.
They share a straight line.
It's a straight line, right? Do you remember what we called that? Two angles that make a straight line is a linear pair. So you can just say there, those are a linear pair. Okay. So then they say the measure of angle AOM plus the measure of angle MOC is 180. How do I know that those two angles have to add up to 180? What did they tell us in the step before? Yeah, Jared. Okay, but in the step before, they told us they're supplementary, right? Which makes them a linear pair. So because of this, that's going to be part of our reason for number 2. So we would just say that's the definition of supplementary angles. Okay, because they're supplementary, they have to equal 180. Okay, now step 3. If you look, I kind of color-coded there. Hopefully you can see the difference in the colors. What I did was I took out AOM and I put in what it equals. And I took out MOC and I put in what it equals. What's that called? Take out a point guard, put in another point guard. Which property? That's substitution, okay? So we would say for step 3 here, we did substitution. Okay. What did I do from 3 to 4? To get from 3 to 4, what changed? I added the x's, right? I combined like terms. Now here's the thing, whenever you combine like terms, whenever you just simplify one side of your equation, all you have to say there is simplify. If it makes more sense to you to say combine like terms, I'm fine with that too. But whenever you combine like terms, you just have to say simplify. I just simplified the left side of my equation. Okay, so now you're looking at how did I get from number 4 to number 5? What changed from 3x plus 30 equals 180 to 3x equals 150? What did I do? Daniel. I subtracted 30 from both sides. So if I subtracted 30 here and I subtracted 30 here, then my step is the subtraction property of equality. And you can just write subtraction property. I'm not so concerned about the of equality part. But notice the sentence here, the math sentence, has a plus in it. And a lot of times people see that and they say it's the addition property. But you have to ask yourself, how did I get from 4 to 5? And to get from here to here, I had to subtract 30. So that's the subtraction property. Okay, what did I do to both sides of the equation? All right, so then what do I do from 3x equals 150 to get x equals 50? What did I do to both sides of my equation? Divide, right? So that's the division property. Okay, questions on that? Okay, so that's what we're going to be doing some of today, is just justifying each step of the way. And I feel like a lot of people can solve a problem just fine, but they don't always know why they got where they got. So it's just an exercise in helping you understand why are we getting from point A to point Z, okay? So any questions on that first one? Okay, then there's a few other properties that will come into play that deal more with geometry, and these are the properties of congruence, but they're the ones I already talked to you about in the last chart. Those were just of equality. So the only difference here is you're dealing with segments and angles being congruent instead of letters being equal, okay, variables being equal. So the reflexive property, AB, segment AB, is congruent to segment AB, or angle A is congruent to angle A. Okay, so they are the same thing. If AB looked in the mirror, it would see AB, right? Reflexive. Symmetric property says if AB is congruent to CD, then flip that over. CD would be congruent to AB. Or same thing with angles. If A is congruent to B, then B will be congruent to A. And then transitive property, they do one with segments and one with angles, and then they do another one with angles that looks a little different, but it's still the transitive property, okay? So if AB is congruent to CD and CD is congruent to EF, we can take out the CD and we're left with AB congruent to EF. Same goes for if A is congruent to B and B congruent to C, take out the B's and we're left with A congruent to C. But then look at this one. This one says if B is congruent to A and B is congruent to C. So it's in a different order. It's not the two in the middle that are the same, but you still have two that are the same, right? So when you have two that are the same, you can take those out and say A is congruent to C. Okay, so that's still the transitive property. It just looks a little bit different there. I know it's a lot of properties. Bear with me. Can we keep going? All right, so tell me this. What properties do you see? For letter A, 3x minus 1 equals 10, and then it becomes 3x equals 11. Which property is that? Someone said it. Who said it? Raven? That's the addition property, right? If I wanted to solve this, I would have added 1 to both sides. So that's the addition property of equality. And again, I'm not super picky about the of equality part, but it is set equal, which is why they say of equality. What about B? If O is congruent to L and W is congruent to L, then O is congruent to W. What's that one? Daniel.
Symmetric property.
Not symmetric.
Transitive?
Oh, yep. Is that what you were going to say? It is the transitive property of congruence. That's all right. Right, so when there's two things that are the same, angle L was in both of those. So then we said O congruent to W right here. Okay. Third one, the measure of angle E equals the measure of angle T, and the measure of angle T equals the measure of angle E. What's that one? Gracie, you want to try that one? Since you didn't get to try the last one? No? Who's got it? Yeah, Daniel.
Symmetric.
That's symmetric, right? So if you're just flipping it around, that is the symmetric property. Technically, this is the symmetric property of equality, and this transitive was of congruence. But again, not picky on that. Any questions on that? I'm going to give you one more right here. What if I said 2x equals 20, so x equals 10? Which property happened there? Yeah, Jerry. Division, right? We divided both sides by 2. What if I said x over 3 equals 9, so x equals 27? What's that one? That's multiplication. I multiplied both sides by 3, okay? So this one was division, this one was multiplication. All right, any questions on any of those properties before I talk you through a proof here? Okay, we're gonna just look at a 2-column proof, which is majority what you're gonna do. Sometimes in the book, they're gonna say write a paragraph proof. we don't like paragraph proofs. There are a lot of words. We like numbers, right? Math is numbers, except for chapter 2. So whenever the book says write a paragraph proof or write a flow proof, you don't have to. You're welcome to, but you don't have to, okay? Every time I give you a proof, it will be a 2-column proof, which means your left side is here's what I did, and your right side is here's the property or the reason that I did it, okay? So we're gonna look just at kind of the general format real quick, and then I'll actually work this proof out. But here's what you need to know about proofs, okay? You will always be given this, okay? Something that's given and something to prove, and then you'll always be given a picture along with it. So basically what happens is you take that picture and you take your given information and you try to prove what they asked you to prove. Okay, so you try to prove the measure of angle AEC is equal to the measure of angle DEB. But here's generally how it works out. In your 2-column proof, you have something like this. And typically, no, always, I think on every single quiz or test or final exam that I give you the number of steps that it should be. So you won't have to guess at the number of steps on assessments. You will probably in the homework more often, but when I give it to you, I will give you the number of steps with it. So let's say this one has 5 steps to it, okay? How it works is you will always put this given information right here. So it's always going to say for our first step, the measure of angle 1 equals the measure of angle 3, and your reason for it will always be given. Okay, so that is one beautiful thing about proofs is you get a free point nearly every time because that first step is always given. Now, the book doesn't always follow that rule exactly. I always give you the given as your first step. Okay, the book most of the time does, but not always. So for every proof, that's going to be your first step and your first reason. Okay, your first step is your given information. The reason for it is given. Your last step will always be what they asked you to prove. So your prove portion here was this, the measure of angle AEC equals the measure of angle DEB. Okay, so the prove portion is always going to go as your last step, and the given portion is always going to be your first step, and then everything else is up to you to figure out, or maybe I will give you the left side and you just have to figure out the right side. Okay, but generally speaking, this is going to be your format. The given first, what they asked you to prove last, and then you fill in the rest. Okay? Any questions just on general format first? Okay, then we're gonna do this proof, but I'm gonna do it on a new setup so that it's not a mess because I have scribbles everywhere. So we're gonna go down here and we're gonna do this proof. All right, so the first thing I'm gonna do is just look at what they gave me. So the given says the measure of angle 1 equals the measure of angle 3. And if you look, that's marked for us also, right? This is marked congruent over here. So we know it just by looking at it, okay? If ever something is marked for you on there, it's given, okay? So here's what we're gonna do. Step 1, what are we gonna say? Right, we're gonna say the measure of angle 1 equals the measure of angle 3. And how do we know that? It's given. Okay, so the measure of angle 1 is equal to the measure of angle 3, so it's given. Okay, now look what we're trying to prove, because if you don't know where you're going, you're not gonna know how to get there, right? So they're asking you to prove that angle AEC, so AEC is this one. Oop, try that again. Okay, AEC is this angle. Can you see that yellow? Kind of. Is equal to DEB, and DEB is this angle, right? So there's some overlap of our two angles, and we're trying to prove them congruent, okay? Here's what you do. In that setup, there is this portion that's identical. So what we're going to say is the measure of angle 2 equals the measure of angle 2, because we're using angle 2 in the first angle and we're using angle 2 in the second angle of what they want us to prove, right? So how do I know that angle 2 is equal to angle 2? Which property is that? That's reflexive. So we're going to say reflexive property. Okay. So then third step, I'm going to say that if 1 and 3 are equal and 2 and 2 are equal, then we're just going to go like this, right? These two put together, so the measure of angle 1 plus the measure of angle 2 should equal the measure of angle 3 plus the measure of angle 2. Okay, because both are equal, we can say they're equal to each other. So if you think about it, we had this, 1 is equal to 3. Okay, 1 is equal to 3. What did I do on both sides of my equation? I added the same thing, right? So that's the addition property of equality. Because all I did was add angle 2 to both sides. Okay, so that's the addition property. So then I can say the measure of angle 1 plus the measure of angle 2 is what angle? Can you name that angle for me? 1 plus 2? Can you name it with letters? One plus 2 would be AEC, right? So the measure of angle AEC. And in that same step, I can also say the measure of angle 3 plus the measure of angle 2 is what angle? That would be DEB, right? These two put together. How do I know that 1 plus 2 is AEC and 3 plus 2 is DEB? You learned it last chapter. It's the angle, what? When I say the two parts added together equal the whole thing. Do you remember which postulate that was? Angle addition. Does that sound familiar? Like segment addition, right? This was angle addition postulate. So for step 4, we're going to say angle addition postulate. Okay. So now what we're going to do is we're going to take away this information here. Because we already said those were equal to each other, right? In step 3, we said those were equal. So now we can say the measure of angle AEC is equal to the measure of angle DEB. Why? If I took out the two that were the same and set the rest equal to each other. And you have two options here, technically. Which property would that be? What? Transitive, or what's the other one you could use here? Substitution, right? So I don't care which one you give me, transitive or substitution. They would both work there. But you're taking out the two that we know are already equal, and we're setting it equal to what's left. Okay? And I know the first time through proofs like this is like, what the heck did you just do? I get that. Don't stress about it, okay? I just need you to be able to ask yourself the question, how did I get from here to here? How did I get from here to here? Most of the time, I'm going to be giving you all of this, and that's usually the hard part to come up with. You just need to ask yourself, like for step 3, how did I get from 2 to 3? For step 4, how did I get from 3 to 4? So look at the step above it. How did I get to the step below it? And then that's going to give you your reason, okay? But it's going to be a lot of the properties, and then anything you learned, like chapter 1. So angle addition postulate or segment addition postulate. So like in the homework, if you see like AC plus CD equals AD, right? That's saying a segment plus a segment equals the whole segment, like this. Here's A, here's C, here's D, right? That would be segment addition postulate as your step. So just pay attention to that, angle addition, segment addition, and then all the postulates and properties that we talked about today, and you should be in good shape. Questions on that?